Hello, beautiful people. This is a continuation for your homework, Chapter 4, Are You Ready packet. This is from previous chapters. Reminder that on every assessment, I do provide extra credit questions. So from our Chapter 4 exam, or on our Chapter 4 exam, you'll see questions from Chapter 1, 2, and 3. These are just sample questions. The full review for your extra credit opportunities, you need to go back to your previous exams from Chapters 1, 2, and 3. All right, let's go and get started. I do have my formula sheet out from Chapter 1. And because we're talking about 3D shapes, a rectangular prism has a length of, and I'm actually going to pause here, and I'm going to take a look at a rectangular prism. So prism is here, and we have the volume, lateral area, and surface area formulas for a prism. Now, I don't know which one I need right now, so I'm going to hold off, but I know we are talking about a prism. If we keep reading, we have the length of 23 centimeters and the width of 19 centimeters. If the volume, I'm going to pause again. Now we're talking about a volume of a prism that is 6,555 centimeters cubed. So I'm going to pause here because they already told us that the volume, let's see if I can spell correctly. The volume of a prism, and I'm going to write this formula down. This is the base area times the height of the prism. Now, if you want to draw a picture, you're more than welcome to. Here's a rectangular prism, looks something like that. And it has the length of 23, a width of 19, and we want to know what the height is. So height, length, width. So length, let's say, based off of my drawing, this can be 23, this can be 19, and we don't know what that height is. But we do know that we have the base. So my base, I'm going to have my base as the bottom. So this is the bottom of it. So I would have 23 and 19. This is a rectangle. So to find the base of the area, we're going to multiply this 23 times 19. And then again, we don't know what the height is. The height is unknown. But one thing they did tell us is that we have the volume. I'm going to separate this out. Here's kind of like my thinking bubble, what was going on in my brain. Now let's go ahead and actually solve it. Volume was 6,555. The base area is 23 times 19 times the height of the prism, which we don't know what that is. We're going to pick up a calculator. And you have a choice to make. You can go ahead and multiply that 23 times 19. Or you can immediately start dividing by that 23 times 19. I'm going to go ahead and multiply since I already typed it into the calculator. Divide by this 437. 6,555 divided by 437 equals, and that gives us a height of 15. Now be careful, I am going to cross this out because it is asking us for the height, we need to have units. So 15 centimeters is your height. Make sure that you have units in your answers. Moving on. A cylinder, pause. Now we're talking about a cylinder. And a cylinder volume of 1,000 inches cubed. So we're going in here. Here's a cylinder volume. So I'm going to use this bottom formula here. Now, it is the same formula as a prism. Cylinder is a type of prism with the bases being circles. So it's a specific type of prism. We call it a cylinder. So the base area is going to be the area of a circle. So volume of a cylinder is equal to open pi r squared, close it, times the height of your cylinder. Volume they do provide us at 1,000. If all the dimensions are cut in half, what is the new volume? So if we continue here, I don't know the radius. I don't know the height of the cylinder. So there's too many unknowns for us to continue on using the volume formula in order to solve something we have. So I'm going to again separate this out. So this is what was going on in my brain, and I'm actually going to cross this out. When they are talking about dimensions, all dimensions are cut in half. This is talking about scale factor. And the formula for the scale factor, we have the old volume times our scale factor. Now, since we are at a volume is always cubed, so we're going to cube that scale factor, and that's going to give us our new volume. Now, we can do the same style for surface area, except surface area would be squared. Old volume was 1,000. Since we are cutting all dimensions in half, my scale factor is 1/2. We are cubing that, and that's going to give me my new volume. So if you're typing this into the calculator, it kind of gives you the answer really quickly. So 1, 0, you cannot see that. Let's see here. 1, 0, 0, 0 times open 1/2 caret 3 equals, so my new volume is going to be 125. What's my units? Inches. Volume is always cubed.
All right, beautiful people, we interrupt this program to let you know that Ms. Romadias is a human and humans make mistakes. So I am going to re-record this section. Hopefully that if you originally saw the original version, you were screaming at the screen letting me know that this is a decreasing function, so we are going to go downhill. Let's go ahead and try this again. We're going to pick up our function negative, open x minus 2, close it, open x plus 4. I'm just copying down the function g of x, all right? Next, this is in intercept form. So what we're going to do is we're going to identify our p's and our q's. And when we do that, we're going to do opposite of what we see. So we have a positive 2 plus negative 4. We're always going to be dividing by 2. So this right here, if we type it into the calculator, we got 2 plus negative 4 divided by 2, which gives me a negative 1. This is my x value. So this x value is going to be my axis of symmetry. With my axis of symmetry, we're going to plug in that x value into my equation and get an output of y. So this negative 1 is going to go inside of x here and inside, negative of x here. Okay, moving on, we're going to type in exactly what we see, parentheses and everything. So negative, open, negative 1 minus 2, close it, open, negative 1 plus 4, close it, equals, and we get 9 is equal to y. Combining the x and the y values, this is going to be our vertex. So our vertex is at negative 1, 9. Now, in this format, this is called an intercept format because we are going to have our p's and q's, which are our x-intercepts. Now again, opposite of what you see. So I'm going to have a positive 2, 0, opposite of what you see, a negative 4, 0. Now your axis of symmetry should always fit between these 2 points. Let's go ahead and graph, and I'm going to pause here for a moment, making sure that I don't make the same mistake I originally did. So negative 1, 2, 3, 4. Here's our x-intercept. Then we got 1, 2. Here's our x-intercept. Axis of symmetry is at negative 1. Make sure you mark it with a dotted line. Then we have our vertex at negative 1 and positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to connect. Swooping down, this is quadratic, meaning we are going to have a U shape. Now again, this is a negative function, okay, negative. So we are going to be decreasing, which means we're going to be going downhill. So we sometimes say with a quadratic that this is a frowny face. We're smiling downward. All right, beautiful people. Hopefully there's no other mistakes. Please do not hesitate to ever let me know that I've made a mistake. I understand I'm human. Things happen. Let me know so that way I may learn from my mistakes. All right, go ahead and keep watching. Thank you.
Moving on. Chapter 2 still. This is solving your systems. We have not done this in a little while. Step number 1, you're going to choose the top two. 3x plus 3y minus 6z is equal to negative 15. 3x plus 1y minus 4z is equal to negative 9. You're going to select a variable to eliminate. I am going to choose 3 x's to eliminate. And I'm going to ask myself, do I add to eliminate or do I subtract to eliminate? So 3 plus 3 is not 0. So that means 3 minus 3, I need to subtract all of my variables here and constants vertically. So 3 minus 3, that's gone. We remove it. Then we have, I highly encourage this step to use a calculator. Sometimes the negatives, they trip you up. So we got 3 positive minus 1 positive y. So here we got 2y. Negative 6 minus negative 4, here's that double negative, minus 2z is equal to negative 15 minus negative 9, and I get negative 6. Now, here is where I'm going to ask you to simplify if you can by dividing everything by 2. If you can simplify in this step, go ahead and simplify. Sometimes you end up with really large numbers if you don't simplify. So we get y negative z is equal to negative 3. This is your first thinking bubble. Now we're going to take the middle and the last equation. Now remember, in step number 1, yes, you have a choice of what to eliminate. In step number 2, you no longer have a choice. If you eliminated x in the beginning, now you don't have a choice. You must also eliminate x in step number 2. Now notice that our x's are not the same. And because they're not the same, I am going to make them the same. You have a choice to multiply 3 by either a negative 2 or a positive 2. I'm just going to do positive 2. If I remember correctly, I do recall on the chapter 2 exam, the issue is with the distributive property. When you were distributing a multiplier, for example, like 2, you would forget to multiply it at the end. So draw your arrows. It is helpful. So we got 3 times 2, which is 6, x. 2 times y is positive 2y. And we got negative 8z. And negative 9 times 2, which is 18. Here, below it, nothing changes, so we're going to stay the same. We got 6 x's minus 4 y's minus 2 z's is equal to 0. Again, how do we remove your x's? We chose x's in step number 1. Now we have to choose x's in step number 2. And that is by subtracting. So we're going to subtract 6 minus 6 here, here, and here. Okay, remove. We got, use a calculator here. 2 minus negative 4, I get 6 y's. Negative 8 minus negative 2, I get negative 6z. And 18 minus 0 is 18. Again, simplify here if you can. So we get y minus z is equal to 18 divided by 6 is 3. Here we are. Oh, and I almost made it. I hesitated because I'm like, these kind of look the same, right? I have a y, a negative z, negative z. I have a 3 negative, but I have a 3 positive. So I was thinking, what's going on? So the issue that I ran into and I made a mistake is I forgot that my 9 was negative. So I'm going to put a negative here on 18. Oh, you cannot see that. So be careful with your symbols because I almost made a mistake. So now we have negative 18 minus 0, which is a negative 18, making it a negative 3. So again, I almost made a mistake. Actually, I did make a mistake. I just found my mistake. All right, so step number 1, choose a variable. Step number 2, choose that same variable. Simplify if you can. And then you're going to write your 2 bubbles on top of each other. So your 2 thinking bubbles, your two variable systems now, you're going to write them on top of each other. Take these 2 y minus z is equal to negative 3. Y minus z is equal to negative 3. Now, yes, they are the same. So you are choosing one of the variables to eliminate. Don't let the fact that they're the same like intimidate you. Just go with the process. Here's y and y. So I'm going to eliminate that by subtracting. And we keep going. These remove. Negative 1z minus a negative 1 gives me 0z. Negative 3 minus a negative 3 also gives me 0. So 0 equals 0. Now, some of you decided that this is where you're going to stop working. Please do not stop working. This means, yes, this isn't always true. That means there are infinitely many solutions, but this is not your answer. That means you have a dependent, I'm just abbreviating it, dependent answer just for space. Okay, because you have a dependent answer, you're going to pick up one of your thinking bubbles. It doesn't matter, they're the same. And you're going to solve for one of the variables. Now, usually you'll see one that's a little bit easier to solve for. So for example, I'm going to add z to both sides. Y is equal to z minus 3. Okay, so what does this mean? This means that y is dependent on z, which then means that z is your independent. Okay. Then you're going to choose one of your originals. And your original that I'm going to choose, I usually don't think too much about it. I just choose the top one. You can't choose the one that's the third one just because it's 0. But again, I usually don't think too much. I just open up here for the top one. Okay, so you have to be careful here. What do we have? What do we need? We have, usually I kind of write this off to the side. So we have 3 letters, X, Y, and Z. Z, we already decided this was independent. Y, we already decided was Z minus 3. So we need to solve for X. So when we are doing this, we're going to keep your X. We're going to open up for Y because we have Y. And since Z is independent, we have to keep our independent variable. We're going to put in the Z minus 3 for Y. And now we're distributing that 3, positive 3. 3x plus 3z minus 9 minus 6z is equal to negative 15. And again, what's my goal here? Don't forget, because sometimes you do end up with 2 variables. My goal is to solve for x. X is what I want. So let's combine like terms, get rid of things. We got 3z positive, 6z negative. Negative 6 plus 3 is a negative 3. Again, what's my goal? My goal is to solve for x. So I need everything except x to be on the other side. Negative 15 plus 9. Get negative 6 here. That's gone. Add 3z to both sides. And I'm running out of space per usual. And when you're dividing this 3, divide all terms by 3. I'm going to steal a little bit of space from our next question here. And we have x is equal to z minus 2. Okay, so now that we have our x, our y, and our z, we got to write our answer. None of this is our answer, okay? So I'm trying to find space. I'm going to write space all the way up here for our answer. Our x was z minus 2. Our y was z minus 3. and our z was independent, so we keep it. Okay. Question number 15, solve for all roots. So here is your question, your actual question from chapter 3. Step number 1, we're going to try to factor, see if that works. And this is more of a question. It's like factor. Can I factor? So I'm going to try by grouping. I see 1, 2, 3, 4 terms. Do I have a GCF that I can remove out of all of them? So I have an X, 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 no X. I have a 4, 9, 6, 1, no. Next, I'm going to try my grouping. So I can already see that it's not going to work, but I am going to try to show you. So I'm going to remove an X squared, giving me 4x minus 9 here. And I'm going to remove a 1, leaving 6x minus 1. Since these do not match my leftovers, that means factoring does not work. And I have to move on to step number 2, which is the rational root theorem. Rational root theorem is your silly snake. I'm going to take my 1. That's the tail of the snake. 4 is the head of the snake. And so then I'm going to put the tail over the head. So I got 1 over 4. Writing out your factors, plus or minus 1, plus or minus 1, plus or minus 2, plus or minus 4. And then all of my numerators get a denominator. So 1 over 1, 1 over 2, and I only have one numerator. So this one makes it a little easier. So plus or minus 1, plus or minus 1/2, plus or minus 1/4. These are possible. Some of you in chapter 3 decided this is where you were going to stop. You can't stop here. These are telling me 6 different roots that could potentially be an answer. It could be that they're not the answer. We don't know, so we have to keep checking. Next, we're going to open up our given polynomial. If you did have a GCF, we don't, but if you did have a GCF, you would use the one after the GCF. And I'm going to start by typing in, I usually type in -1 first, just because then I can erase the negative easier. Okay, so -1 doesn't work. One does work. So step 4, that means x is equal to 1. And I'm going to go in with synthetic division. Be careful if you're missing anything, you have to put placeholders. So we got 3, 2, 1, 0. So no terms are missing. Make sure you're okay with the negatives versus the positives. Now here you have to have a remainder of 0 to make sure that 1 is in fact a root that works. Bring down 4, multiply on the outside, add on the inside. The remainder is 0, so that means it checks out. This is your remainder. This is your x0, x1, x2. Step number 5, you're going to write out what you have. And then you're going to start your round 2. Now, round 2 is you're going to try to factor. I see a trinomial with the leading coefficient that is not 1. I'm going to use your rainbow method. And here we can, yes, factor x minus 4, x minus 1. Now on chapter 3 exam, this is an issue that I saw. With rainbow method, you have to, if you multiply by 4, you have to then take your factors and divide them by 4. So then what we have is x minus 1 as a factor, 4x minus 1 as also a factor. I'm going to put these in a thinking bubble. None of this is our answer. Let's go ahead and write out our answers. Our answers are in the format of roots and factors. And we start out with our first root. That was step number 3, step number 4. In step number 4, we got our first root of 1. I'm going to draw an arrow, which means this one right here, came from an invisible factor. We did not see this, of x minus 1, comma. Then we take our other factors of x minus 1, bring that down. That means we have another root at positive 1, opposite of what you see. Then I have a factor, oops, no comma here. Only commas on the roots, not on the factors, of 4x minus 1, which gives me, set this equal to 0, solve, which gives me a positive 1/4 as a root. Okay, again, difficulties with the answers because I have multiplicities. That means my factors are x minus 1 squared and 4x minus 1. That means my roots are 1 with a multiplicity of 2 and 1/4. This right here are my roots and my factors. Okay. Alrighty, let's see. Oh, we do have one more page. Let me show you the answer one more time. That was the answer. One last page, it is asking us to factor. 2 factoring questions. Step number 1, what do we see? We see a trinomial. Do I have a GCF? Well, I have an x squared. See if I can highlight this for you. An x, and an x. So I know I can divide by x squared. But I'm also thinking, can I pull out a number? Can I divide out by a number? I see 9 as my smallest number. You always go to the smallest number to see if any of its factors. 41 is going to give me a hard time. Can't be divisible by 3. Can't be divisible by 9. So unfortunately, we don't have a numerical GCF, just x squared. After we divide everything, we end up getting 20. Subtract these. So 6 minus 2 is 4. 4 minus 2 is 2. And this is just 9. Then we see that we have a quadratic pattern. 2 times 2 is 4. So that's our check. It is a trinomial leading coefficient that's not 1. So we need to use the rainbow method. 9 times 20 is 180. And now we start our guess and check game. This middle x squared that's in the middle, that's the one that you're going to always pick up and write in your factors. Next, how do we check for factors? Well, I'm going to start out with 180, and I'm just going to go divided by 2. I always start with 2. I'm going to ask myself a question. 2 plus 90, is that 41? No. 90 minus 2, is that 41? No. So then I move on to 3. 3 plus 30, is that 41? No. 30 minus 3? No. That one's not a pretty number. We want whole numbers. Nope. Oh, that's wrong. 41 divided by 3. No. 41 divided by, oh my goodness, let me try again. I'm trying to go too fast. 180 divided by 2. This does not work. 180 divided by 3. This does not work. Okay, so ignore the other calculator things. That does not work. 180 divided by 4. Does this work? Yes. 45 minus 4 is 41. So we get our factor of 45 and 4. Now, here's where you have to be careful with your positives and negatives. So I need a negative 41. So the negative goes on the larger number. That means 4 is positive. Now, again, same issue as last time. If you've multiplied by 20, that means you have to divide your factors by 20. Another issue I saw in chapter 3, you didn't simplify your fraction. So 45 over 20 can be simplified. Now, if you do it like this on the calculator, it's going to give you a mixed number. So I'm going to cheat. I'm going to go 20 divided by 45, understanding that, yes, I did flip my fraction. So whenever I see on the calculator, I understand that this is not what I have typed in, so I'm going to flip it. X squared minus 9 over 4. And again here, 4 over 20. See if that simplifies, and it does. X squared plus 1 over 5. Since, yes, now we still have denominators, I have 4x squared minus 9, 5x squared plus 1. Now, you're not done. You still have to check. This one here, I see a exponent of 2, so it's a binomial. It could be of quadratic pattern. I have to check. Yes, I can take a square root of 1. No, I cannot take a square root of 5. So this one's done. And this is because of this 5. It fails. Now here, I do see an exponent of 2. Can I take a square root? And I have a minus. Sorry, that's another check, minus. This fails because also it's a plus. Can I take a square root of 9? Yes. Can I take a square root of 4? Yes. So that means that I need to acquire my a value, which is 2x, and my b value, which is 9. Now this is your, that's wrong. Take a square root, which is 3. Okay, so now that we have our a and b, this is not the factored, okay? This is not factored form. This is in a thinking bubble so for us to understand where is your a value versus your b value. Now your actual pattern is 2x plus 3 for quadratic and 2x minus 3. This is your difference of squares. Bring down your 5x squared plus 1. Did we have a GCF? We did have a GCF. And that is x squared. And this is your answer. We know this is linear. This is done. This is linear. This is done. This doesn't have a pattern. That's done. And our GCF is just our GCF. Okay, final question. Let's go ahead and factor. Do I have a GCF? Well, I have an x, no x. I'm going to see if 4 and 108 get along. And they do. So I'm going to divide by 4. So I'm going to have a GCF of 27. That's wrong. GCF of 4, and my leftover is 27. So 4 divided by 4 is 1. I get x cubed minus 27. Okay, so now we see a binomial. Yes, it has a minus, but the exponent is 3. So this is of cubic pattern. So I'm going to take the cube root of x cubed and the cube root of 27. Ignore the minus. That means my a value is just x. And the cube root of 27, you can check on a calculator if you want. 3 second caret 27 is 3. Again, this is not your factoring. This is your a and b value that you need to use to factor. So your pattern is going to be a squared, b squared all the way at the end, and then in the middle, a times b. Now the symbol is, now we pick up the symbol, always same, always different, and then always positive. Now that we have our setup, then we take our a and b's and we plug that in. So x minus 3, x squared plus x times 3 plus 3 squared. Simplifying that out, we have x minus 3, x squared plus 3x plus 9. Did we have a GCF? Yes. So don't forget that. Again, that was an issue on the previous exam. We did have a GCF of 4. So that is part of your answer. If you don't write that GCF, the answer is wrong. And that is your last question. All right, beautiful people, that is it. Reminder, Chapter 4 exam will have extra credit on it. So please make sure you are reviewing your exams from Chapter 1, 2, and 3. This is not, I want to make sure, this is not like a sample of the extra credit questions. These are just random questions that I put in from previous chapters. For the full review of possible extra credit questions, please refer to Chapter 1, Chapter 2, and chapter 3. Thank you.